Titration calculation. There's two ways of doing it. We've got the balanced equation way. So here we've got hydrochloric acid plus sodium hydroxide giving sodium chloride and water. We can see straight away that we have 1 mole of hydrochloric acid and 1 mole of sodium hydroxide. Okay. What we are looking for is some method of measuring the H pluses and OH minuses, because in a neutralization reaction, which is what this is, they have to be equal. So titration equals a neutralization. So H plus equals OH minus. Now, if we know the acid side, and we know the concentration, and we know the volume, and we know the number of moles on the acid side, that means if it's to be neutralized, we need to be able to work out the same on the base. So if we know the concentration on the base, and the volume of the base that we used, and the number of moles of the base, then they have to be equal. That is, Ca equals acid con, Va equals acid used, Na equals moles acid. Now we get the same for the base. Cb equals base used, base concentration, sorry. Vb equals volume base, and Nb equals moles base. Right, now we've got some of those figures. Remember, the acid concentration was given to us right at the start. We know it's 1 molar. We know the acid that we've used. That was the amount that we added. Now we take the second two, always ignore the first one, and we work out an average. So the second two were 9.1 and 9.0. So the average is going to be 9.05 centimetre cubed. And we know the number of moles used in the acid. It tells us there. We've got 1. Now we don't know the concentration of the base. That's what we're working out. So that's our X. But we do know the volume of the base that we used. It was the same each time. It was 25 millilitres, or 25 centimetre cubed. And we do know the number of moles of the base. Again, it tells us there. We've got 1 of it. So we can transfer these into the equation. Ca is 1. We're going to multiply that by the acid used, which is 9.05, and divide that by the number of moles, which is 1. And that has to equal Cb, which is what we're trying to find, multiplied by the volume of the base used, which was 25, divide that by the number of moles of the base that we had, which were 1. So that's going to rearrange to Cb equals 1 times 9.05 times 1 divided by 1 times 25. Remember, when we're rearranging, whatever on this side changes to below it on the other side and up on the other, yeah? And that's going to equal 0.36 mole per litre. Okay. There is a second method that doesn't require a balanced equation. In this, we look at what we call acid and base powers. An acid power would be 1 if it's got 1 H plus ion, 2 like a sulfuric acid if it's got 2 H plus ions, H2, 3 if it's got 3, and the same with OHs. Potassium hydroxide, KOH, will be of a power of 1. Calcium hydroxide, Ca brackets, OH close brackets 2 would have a power of 2, and so on. So we use the equation acid power multiplied by acid volume multiplied by acid concentration has to equal, if it's neutral, base power times by base volume times by base concentration. Remember what we said, acid power equals 1, or H2 will equal 2 H's, H3 will equal 3. On the base side, NaOH would equal 1 for a base power, CaOH2 would equal 2. That's the idea. Number of H's, power, number of OH's, the power. We can substitute our numbers in that we know from the actual titration. Acid power on this side is hydrochloric acid. So we know it's got a power of 1. The acid volume, again, work out with the titration. Use the second two numbers, always ignore the rough. 9.1 plus 9.0 divided by 2 gives you 9.05. And the acid concentration, we're given at the start, it's going to be 1. The base power, again, sodium hydroxide, 1 OH. The base volume, again, from the titration, we use 25 centimeters cubed. And the base concentration is what we're trying to find. So again, to find the base concentration, these just moved underneath. So we get, well, that's going to give us 0.36 moles per litre. Okay, that is how to do a titration. You need to remember a burette is used for measuring small amounts. A pipette is used for measuring a set amount, and it's a neutralization reaction that relies on an endpoint. The endpoint being when the indicator changes colour.